So I'm here to talk about industrial innovation policy in the U.S. And there's an underlying theme here. You can't herd cats, but you can move the cat food. So the U.S. is not going to do state capitalism, but it can move the cat food and create the necessary incentives. So just as background and backdrop, the U.S. split its basic and applied research systems, really following World War II. Going into World War II, the U.S. was certainly not a science leader, right? That was more dominated by European countries, a series of them. So in the post-World War II era, that was what the U.S. wanted to catch up to. It had come to dominate world manufacturing in the pre-war and course of World War II. So manufacturing was not the problem, right? Industry was not the problem. The issue was really catching up on science and building strong R&D. So we created a strong basic research system, and we disconnected it. In the war, we disconnected it from all of the follow-on applied stages. So in effect, we institutionalized in that immediate pre-war period, and that model remains with us, we institutionalized what we call the valley of debt between the research side and the applied side. And there's very few bridging mechanisms in the US between the two. Now, there was an exception to that general rule. The US Defense Department kept those links between basic and applied. It is long supported in an industrial policy kind of approach. So if you think about all the stages that technology has to get through before implementation, the Defense Department historically in the United States has supported research, development, prototyping, demonstration, test beds, production, and creation of initial markets. Whereas our long-standing basic research science agencies support research and maybe early stage development. So let me also at the beginning do a little definitional work differentiating industrial policy from industrial innovation policy. So the historical governmental role in the US in areas like agricultural support, transportation infrastructure, energy infrastructure, healthcare, those are what we could call industrial economic policy approaches, a broad reach into those overall economics of those sectors. Industrial innovation policy really focuses on that innovation stage, not on the more general economic policies. As all of us know in this room, there's been major opposition from US mainstream economists to a federal governmental role beyond the research stage. And the rationale is to oppose intervention unless there's clear market failures. Now, again, there's an exception to this rule. The Defense Department built a very connected innovation system that helped lead innovation waves in areas like aviation, electronics, space, nuclear power, computing, the internet. And frankly, those are most of the big innovation waves of the second part of the 20th century. So the US has got a parallel universe that operates. It's got a deeply connected Defense Department running a very significant set of connected applied and basic policies, and then it's got the civilian side where the governmental role really is in research. And we can define industrial innovation policy in terms of the well-known stages they've just been discussing that the technology has to go through, from research and development and prototyping and demonstration and so on through initial market creation. We can define industrial innovation policy as a governmental intervention in those post-research phases, and one or more of these. So the U.S. in recent years, really starting in the early 2000s, faced the rise of Asia and China's manufacturing capability. So the U.S. lost 1/3 of its manufacturing workforce between 2000 and 2010. U.S. manufacturing declined in 2020 to 16% of world manufacturing output, while China's rose to 31%. The countries literally traded places. So the U.S. is currently running an $800 billion trade deficit in manufacturing goods, and within that, it's running a $244 billion trade deficit in advanced technology goods. So there was one of the results of all this has been major social disruption in the United States. Rising economic inequality in a country that prided itself on moving towards a much greater economic equality, and a corresponding decline in the U.S. middle class. So within that, between 20 and 22, the U.S. has adopted a series of new approaches to industrial innovation policy. And I'll just run quickly through them. One of the approaches concerned the pandemic, and here the U.S. developed Operation Warp Speed to speed the development of vaccines. Technology demonstrations around what we call the Infrastructure Act, new energy technologies around the Inflation Reduction Act, and semiconductors around the Chips and Science Act. Total, there's over $500 billion in these various programs. And I'll remind everybody that these are fully funded, right? So there's kind of no going back on these. The funds have already been made available. What are the policy drivers? There's essentially three. Initially, the pandemic, and a lot of realizations came out of those pandemic policies. Second is around climate change, and that's not bipartisan in the United States. Third, technology competition, principally with China, and that has bipartisan support. So a difference between the U.S. and a number of the countries here in the room is just the scale of resources that get devoted to this. But I think what is probably more interesting are the policy models that the U.S. has been using. And I'm going to run through 6 approaches here fairly quickly. One we could call a top-down approach. In this top-down approach, government agencies lead the technology development process. And the best example is Operation Warp Speed, the response to the COVID-19 pandemic. This was a wholly governmental cross-agency partnership. It involved multiple departments and agencies, really virtually all of the health agencies plus our Defense Department. It tackled a very deep problem in the U.S. system, the problem of cross-agency collaboration. There were many agencies that had to be involved in this with different authorities. Operation Warp Speed created an entirely new organization, right? It didn't rely on a committee process to talk to each other around a committee table. This involved creating a new entity. Dedicated officials from the different health agencies and defense were allocated and reported to this new thing. And there were 2 leaders drawn from outside of it and outside many of the existing agencies to run it. So the loyalty, the folks delegated from different agencies brought the authorities and capabilities of their agencies with them, but reported to a new thing. Someone in the United States once described cross-agency collaboration as a contradiction in terms, but Operation Warp Speed really tackled this problem with a new organizational model. How did Warp Speed work? It picked winners. That's why it's a top-down, governmental-run kind of entity. But it adopted, interestingly, a portfolio approach of selecting leading companies in 3 different vaccine platform technology areas. So there was a mix of firms here, which reduces the governmental risk of failure, but also reduces the risk of governmental interventions. A key behind Operation Warp Speed was guaranteed contracts. And the government supplied the guaranteed contracts. You can't manufacture unless you've got a customer within sight. The guaranteed contracts allowed risk-taking to scale up the production. And in Operation Warp Speed, the production was scaled up in parallel to the final development stages and vaccine approval processes, so that by the time you got through the vaccine approval stages, which was done in record time, you had manufactured goods ready for shots in the arm. Another element of Warp Speed was technology certification. Our Food and Drug Administration, our drug safety entity, issued emergency use approval to the new vaccine candidates that qualified as safe and workable. That approval, that certification, that validation assures virtually immediate market entry. Only in the life science territory, only in the health science territory, do we have this valuable market-creating tool of certification and validation, and Warp Speed used that. Flexible contracting to speed government procurement, mapping supply chains, direct support of production scale-ups, bringing the right equipment into new factories, and a national distribution system. These are all elements of Operation Warp Speed in what we could call, again, a top-down kind of approach, a governmental-driven approach. But there's another approach, bottom-up. And here we'll look at electric vehicles and Tesla in particular. The government supported a network of incentives to scale electric vehicles. And it's up to the companies to take advantage of these incentives. Tesla, uniquely, saw the opportunity. And, you know, an outcome here is that Tesla has really helped drive all of the world's major car manufacturers by providing a workable model to move from internal combustion engines to electric vehicles. So where did Tesla come from? You know, Tesla's market value this year is $735 billion. That's larger than the top 4 world automakers combined. Tesla was underwritten by federal and state governments at virtually every stage, including a $460 billion loan that kept it out of bankruptcy in 2009, major federal and state tax incentives. I won't go into the fine print, but there's a list there. A third approach, the demonstration project approach. The demonstration phase, as folks in this room know well, you know, follows directly from developing a working prototype. So it's crucial to industrial innovation policy. Only after a technology has been successfully tested and demonstrated really can it move to the initial production stage. So it's a key moment, and one typically where government is not involved. The U.S. in 2021 passed an Infrastructure Act, and that placed a strong emphasis on the demonstration phase of new energy technologies, listed here. A fourth approach involves direct production support. Sometimes it's not enough to promote a general scale-up through guaranteed contracts or tax incentives. Sometimes you really want direct support of production facilities, which is a step, frankly, rarely taken in the U.S. Outside of the defense sector. The prime example here is the CHIPS Act in the U.S. funded in 2022. As everyone here knows, semiconductors are a core enabling technology. The U.S. share of semiconductor production worldwide declined from 37% in 1990 to 12% in 2022. There are key national security implications here. So the CHIPS Act provided direct manufacturing facility construction funding of $39 billion. It also provided an investment tax credit, a tax subsidy of $24 billion, and a loan guarantee program, low-cost financing, of $75 billion. And in addition, $12 billion in research and development, and 2 new manufacturing institutes. So that was a package of direct production support, the likes of which the U.S. has really not done much of outside of the defense sector. Fifth approach of our sixth concerns supply chain support, and here this was run by the administration, of building resilient supply chains and revitalizing production capabilities. There were 4 focus areas in this effort to look at supply chains, pharmaceuticals, advanced batteries, critical minerals, semiconductors. Mapping of supply chains was undertaken at the White House and agency levels in these critical technology fields, and then use of existing agency authorities to kind of fill in gaps. And the last one, in many ways, is the hardest, which is on regional implementation. So the U.S. not only has a serious economic inequality problem, we have a serious regional, geographic a quality problem. Not everybody is on the East Coast and West Coast. There's a lot in between. So what are the models? There's new funding in the CHIPS and Science Act for regional innovation hubs and regional innovation engines. This is the hardest stage, I think, to get right, often quite unsuccessful. What are some of the rules that we've been trying to think about in the U.S.? Obviously, others have been too. One, include a university research institution as part of the mix, as an actor, particularly in solving the talent problems. Success also seems to require an organized public sector, where state and local governments as well as federal support come to bear, working with an organized, connected private sector in collaboration. Success also seems to require both larger firms and their supply chains, a mix of small and large firms. It requires regions to build on their existing strengths. It's going to be very hard to create a biotech hub in North Dakota, but agriculture might make a lot of sense there. So build on regional strengths. Workforce education is key. Systems to form a pool of skilled workers and innovators is just a crucial element here. And rather than being thought about as a separate category, it needs to be integrated into overall innovation policy. And then finally, overall success seems to require a focus not just on a single technology sector, which can go up and down, but on a range of technology capabilities and at least several economic sectors. So these are the 6 basic approaches that the U.S. has been adopting in its industrial innovation policies. It's the policies, I think, rather than the level of resources that are significant. And again, they're top-down, bottom-up demonstration projects, direct production support, particularly when there are national security issues involved, supply chain support, and regional implementation. What have these initiatives done? Well, this is a chart of U.S. manufacturing construction starting in 1960. You see a pretty level line. In the last 2 years, you note that incredible jump up in total manufacturing construction in the United States. Just the best example is that about $52 billion in federal chip manufacturing subsidies, and most of this, virtually none of it has been spent yet because it requires company matching commitments. That $52 billion investment from the federal side has now yielded $834 billion in private investment. There are construction delays, there are regulatory delays behind these programs, but they are shifting into place. So that raises a whole set of structural market problems for industrial policy. And as we all know in this room, industrial policy can create disruptive governmental interventions into markets that can unfairly advantage particular companies, i.e. picking winners, can disincentivize others, and it can disrupt effective market development. So the U.S. has been trying to avoid this. For top-down, Operation Warp Speed picked a portfolio of companies, not single actors. For the bottom-up approach, particularly in energy technologies, these incentives were open to all. So companies self-selected. There wasn't a direct governmental picking. In the direct support programs, that's principally the CHIPS Act, those incentives were available to all that participated and had to compete for them. So I'm not saying we've solved the intervention problems, but they're at least an attempt to tackle them. The U.S. still has a long way to go in building the infrastructure that's going to be needed for industrial innovation policies. We need to get better at nurturing change agents, in other words, scientists and engineers that also have project management skills, because it's going to require a lot of that. We need to do a much better job of connecting across research institutions. We need to better integrate between agencies. Warp Speed, again, is a good example of this. We need to provide technology scale-up financing, and I'll get to that in a minute. We need to do a better job of mapping supply chains. We need technology testing and demonstration and test beds. Technology certification is available in the life science, health science area, but that can be a really critical market entry opportunity. Could we move technology certifications and validations into other sectors, hard tech sectors as well? Flexible contracting mechanisms to speed government procurement, and applying government procurement programs around the technologies that the government wants to nurture. And there's an underlying issue, which is really rebuilding manufacturing topics. That's frankly the big gap in this network of policy approaches. And let me just turn to that in closing. The U.S. needs to do a better job of putting industrial into its industrial policies. And within this industrial innovation policy shift, there's a big manufacturing challenge. And that's, I think, continues to be the major gap. The manufacturing challenge, it essentially is if you don't manufacture, the benefits from industrial innovation policies become very indirect. In effect, you have a risk of jobless innovation. And the innovation learning from science and engineering behind the production process gets lost. So the U.S. hasn't adequately addressed this manufacturing challenge yet. We know we need to move towards advanced manufacturing. Without efficiency and productivity gains, to lower production costs, the ability of the U.S. to compete becomes problematic. Just a few charts to illustrate some of the issues. The U.S. has got stagnating manufacturing productivity problems. You can see the purple line at the bottom of that chart compared to a number of competitors. It's particularly a problem for small and mid-sized companies. These are the firms in the U.S., and that's half of U.S. output almost. These are the firms that lag in manufacturing productivity. You can see the small and medium firms are at the bottom of the productivity chart. And of course, therefore, the small and medium firms are also behind on the capital plant and equipment investments that lead to improved productivity. So what are we going to do? I mean, there's a series of kind of fixes we need to think about. We have 17 advanced manufacturing institutes. They need significantly larger resources and some improved capabilities in their programs. The ability to kind of network the institutes better and connect their technologies, better ties to the underlying R&D agencies so that early stage R&D is moving into follow-on stages, and then pulling in more small manufacturers, which have the worst productivity problems. We need to back R&D for manufacturing technologies. Again, the U.S. at the close of World War II didn't see manufacturing as its problem. It saw it as a huge advantage. We now understand that manufacturing is a gap. We didn't put our innovation system into manufacturing. We skipped it. And that turns out to be, a very serious ongoing problem. So tying the basic research organizations to the follow-on applied stages becomes quite important. Providing scale-up financing. U.S. venture capital funds software, biotech, and some services. It does not fund hard tech. And that's a very serious problem if you want to have a big piece of hard tech economy. Direct production support for critical technologies, particularly with national security connections. Mapping and filling supply chains. Importantly, fixing workforce education so it's part of an ongoing assumed strategy on innovation. And creating a leadership mechanism that's able to cut across the agencies. That's probably going to require a White House office. The biggest of these manufacturing gaps is really in scale-up financing. So the U.S. has been focusing on these kind of critical technology areas, right? Chips, new energy technologies. But that's only the tip of the pyramid. Below that tip is a huge base of ongoing manufacturing that hasn't been receiving any attention. We've been focused on critical technologies. And yet that base is the support system for those critical technologies. So a scale-up financing capability, I think, could be key, and it needs to reach that much larger pyramid foundation. So we need a scale-up mechanism. To wrap up here, the U.S. is pursuing industrial innovation policy at scale with the 6 policy models that I mentioned, top-down, bottom-up, demonstration, direct production support, particularly where there's a national security connection, and regional implementation. So we need to put the industrial back into industrial innovation policy. And that means in turn that we need stronger manufacturing initiatives and incentives. Industrial policy involves risks and involves many actors. It is like herding cats. But you can move the cat food and create these incentives to move in that direction. Thank you.